All right, example 5 from 8.1 in algebra, where we are finding the surface area of a triangular prism now. And the idea of finding the surface area of a triangular prism isn't much different than finding the area of a box, but we're dealing with triangles now instead of rectangles, so things are a little bit different. And we'll notice that we have a right triangle right here on this side, and then this other triangle right here is also a right triangle. These two triangles are exactly the same. So we'll need to find the area of each of those triangles, but once we have one, we'll be able to find the other. And then we'll also want to find the area of each of the rectangles that kind of go around those triangles. So there's a rectangle right here. There's also a rectangle kind of on the back side there, and there's a rectangle on the bottom. So let's first start with this rectangle that's kind of right here that has this kind of height and then this length. The length here is 20 because we can see that. But this length right here, we're not given. However, we are given enough information to find this length because this length right here is the hypotenuse of this right triangle. And we are given these two sides. We know the legs of that right triangle. It's 12 and 5. So if we're given 5 and 12, we can find the hypotenuse by using the Pythagorean theorem. So we're going to do 12 squared plus 5 squared will be equal to c squared. That's going to help us find this length right here, the hypotenuse of that right triangle. We have A, we have B, and we're looking for the hypotenuse C. So I plug those in. I get 12 squared plus 5 squared equals c squared, which is 144 plus 25. That equals c squared. 144 plus 25 is 169. That equals c squared. So to find c, we square root both sides of this equation here, and the square root of 169 is 13. So what that means is that 13 is this length right here. So therefore, the area of this rectangle, that's a 13 by 20, is 13 times 20. This area is 13 times 20. The rectangle on the bottom is going to be 5 times 20. And this rectangle on the back side is going to be 12 times 20. So we have those three areas there. We're going to need each of those. And then we'll have to find the area of the two triangles. But first, let's kind of put this first one together. So we have a 13 by 20. That's this one. 13 times 20 is that area. Plus a 12 times 20. 12 by 20 is this back rectangle. And then 5 times 20 is the rectangle on the bottom there. That's not all. We need the area of the triangles. How do we find the area of a triangle? It's 1/2 the base times the height. So if I look at this triangle, the base is going to be 5, and the height is going to be 12. I know this is the base and this is the height because the base and height of a triangle are always perpendicular or form that right angle. And there are two of them. So I'm going to tack on 2 times 1/2 times the base times the height. So here's that area for a triangle formula here. 1/2 times the base times the height. 1/2 times 5 times 12, and then I'm multiplying that by 2. Where does this 2 come from? Because there are two triangles there. Then I just have a long string of an expression I got to simplify here. 13 times 20, 12 times 20, so on and so forth. What I get here is 260. That's 13 times 20. 240 is 12 times 20. 100 is 5 times 20. And then 60 is 2 times 1/2, which is 1. Times 12, which is 12, times 5, which is 60. So 260 plus 240 plus 100 plus 60 is going to give us the surface area of this triangular prism. We found the areas of all of the shapes that make it up, which will end up being 660.